Differential equations 4.2 day 2. We're really getting into the usage of what we had just seen. Now, please remember that everything that we are using the formula for today is for a second order homogeneous differential equation. And you will be given one solution, and you're supposed to find another as well as the general solution. You can see in green here where we left off with that first video. That's the key. That's really what we'd like to have. So look, they're giving us this y double prime. Here we've got 0y prime. And you can see this is going to be a minus y, so we could say plus negative 1y equals 0. And that means that our p of x is equal to 0. So we're going to use this green highlighted formula right now. They're telling us that y sub 1 is e to the x. And then we're going to have this integral. We'll have e to the negative integral of 0 dx. And down below here, we're going to have e to the x, y sub 1 squared. And then we just have to clean this up. Well, obviously, if you have an integral of 0, you're actually going to arrive at a constant. And down below here, we'll have e to the 2x. Now, e to a constant is a constant. So I'm going to just pull that out as a c sub 1. And then we'll have this as e to the negative 2x. You know, imagine that's just a 1 up here. As I go ahead and I take my antiderivative, I'm going to have to reverse the chain rule. And that's going to get me e to the negative 2x, divide by negative 2, and then we'll say a plus a second constant. Now, from here, we can go ahead and distribute. And when we do that, we'll get c sub 1 really over 2, e to the x times e to the negative 2x. Well, you add those two powers together, you'll get e to the negative x. C sub 1 times c sub 2, well, that's a third constant, and we'll have this just as so. Do want to point out to you right now that you pretty much know what your second solution would be. You were told that the first answer would appear to be e to the x. The second one, well, you can see right here, it would be e to the negative x. And then in general, we're going to have all possible linear combinations. We could say c1 over c2. We could have called that c sub 4. The beautiful thing is this formula will lead you to that general solution too. It's so nice for the general solution, of course, when you have the homogeneous differential equation. So that's how we're using that formula and how wonderful it is. It speeds up the process immensely. So let's take a look at a second problem, last one of the day here. You know, we have a p of x right here, which happens to be 2. You can see that very, very quickly. And our y sub 1 is right over here. So if we were to recopy that formula, it's only going to take us a moment to get that cleaned up. So our y sub 1 is a lot more involved. The other day when we had an answer that looked that involved, well, it wound up being a little bit messy for us. And that's okay. We're going to definitely get this cleaned up. So just have to walk through and do some simplifying. What's the antiderivative of just that 2? Well, you could pretty much see it's going to be, so we look at our numerator, a 2x. And we can distribute that negative in there. But of course, that's also going to have a constant come in. Here, when we distribute, we'll have an x squared and this is going to be a power to a power, so we're going to multiply. That's e to the negative 2x. And here we go again. Wow, we're going to see this so very much. We might as well really make use of it. E to a constant is going to allow us to bring a constant out. And we're going to bring that out right now. So I'm going to say here's a c sub 1 x e to the negative x. And then look at this. Look at your numerator. You'll have e to the negative 2x. Here's an x squared. Here's an e to the negative 2x. And all of a sudden you see something wonderful. This e to the negative 2x and this e to the negative 2x is going to wipe out. And wow, I bet you can see we're actually getting close to being done here. We just have to take our antiderivative of this x to the negative 2. And when we do that, guys, you can see that we bump that up to get x to the negative 1. And then we divide by that. It won't take you long to see that's negative 1 over x plus another constant. Well, distribute. And I don't think it's going to take you too long to see what's going to happen here. C sub 1 x e to the negative x times a negative 1 over x plus, well, a c1 times a c2. It's another constant. You could just call it that, x e to the negative x here with a third constant out in front. But look, this x and this x are going to cancel out. A negative could just get absorbed into a constant, of course. You could just leave it like that. And guys, this is the super, super, super cool part. This is your general solution right here. This is your general solution. Now, they might ask for the second solution. They'd say, look, we told you you had x e to the negative x. Well, what's your second solution? Well, you can see in the general solution it's e to the negative x. So they very likely are going to ask for both. But this is the benefit of having that formula. That formula is going to allow us to solve these problems nicely and quickly.